For the circuit shown in figure, find the voltage across J5 ohm reactance. The power supply is 50 angle 0. Let us assume that we'll write loop current method I1, I2 are the loop currents in that circuit. So we are traveling from A to B, then C, then D, then A. For the loop A, B, C, D, A. Plus 50. Why? Increase in potential. Plus 50. 0 degree. Then the current direction is I1 is in this way. That's why there is a drop in potential. Minus 3 plus J4. 3 plus J4. We are considering these two together. Why we are considering always resistance and the inductance together? Because no inductance without resistance. No inductance without resistance. We put separately, but the resistance is inside that inductor. Resistance is inside that inductor. That's why 3 plus J4. Minus. Why this minus? Because we are traveling along current direction. We are traveling along current direction. That's why 3 plus J4 minus. What is the current through that? I1. Again here what is the current here? I1 minus I2. I1 minus I2. I1 minus I2 and I1 direction are same. Both are entering through the dot. Both are entering through the dot. Now first let us write for this J5. Minus. Why? We are traveling along current direction. That's why minus J5 I1 minus I2. Now this J2 is because of mutual inductance. J2 is because of mutual inductance. J2 is positive or negative? Positive or negative? Positive, because I1 is entering the dot. I1 minus I2 also entering the dot. Both currents are entering the dot. Now we are considering I1 minus I2. What is current in L1? Let us assume that this is L1. This is L1. Let it be L2. L1 current is entering through dot. In L2 also current is entering through dot. That's why positive. So J is positive plus J2, that is positive. We are traveling along current direction. What is current in that? How mutual inductance comes into picture? How to mutual? What is the voltage drop across that mutual inductance? What is the voltage drop across the mutual inductance? For that, this current or that current we have to consider. This mutual inductance because of what? There are first let us 1 minute. We'll do one thing. Here one mutual inductance J2 is there. Another mutual inductance is here. That is also another J2. This J2 plus or minus. This J2 is because of L2. Because of L2. This J2 is because of L1. Am I correct or not? Okay. Here J2 is positive or negative? Positive, because here and here current is entering in the same direction. That's why positive. What is we are traveling along current direction, I1 direction. That's why minus J2 I1. Here also this is also positive. That's why first we will put J2 positive. We are traveling along I1 minus I2. That's why current direction minus I1 minus I2. equal to 0. Equal to 0. The blue color inductors are virtual inductors. It is not visual. It is virtual inductors. It's the effect. It's the effect in that coil. This is not physical. This J2 is not physical. Not physical. This is virtual. This is virtual. This is also virtual. This is also virtual. We are assuming that it is there. I understand this. Okay. Now we have to simplify this. Now let us write -3 minus J4 I1 minus J5 I1. Here minus J2 I1. Here minus J2 I1. If you add all this together, minus 13 J13 I1 minus 3. So minus 3 minus J13 I1. And all I2s let us add. This is plus J5 plus J5. Then another minus, this is also plus minus plus J2. So J7 I2 plus J7 I2 equal to minus 50 angle 0. Or I can say that 3 plus J13 I1 minus J7 I2 equal to 50 angle 0. Let it be the first equation. Let it be the first equation. Now we have to write the loop equation for second loop. Second loop, we are traveling from for the loop EF DCE. EF DCE. If we travel from E to F, what is the current? I2. We are traveling along current direction. That's why minus of minus J6 I2. Why minus? Traveling along current direction. What is current here? Current in this coil is I2 minus I1. I2 minus I1. Now I2 minus I1. Earlier it is I1 minus I2. Now I2 minus I1. We are considering I2 is the correct direction. I2 minus I1. Okay. Now, if you consider this J5, here I2 is entering, leaving the dot. I1 is entering the dot. That's why minus, this J is minus J2. For this, for the second loop, minus J2. Why minus J2? First loop we considered plus J2. For second loop it is minus J2 because I2 is leaving the dot. I1 is entering the dot there. In both dots are in opposite direction. That's why minus J2. We'll write that later. J5 you have to write, we are traveling along current direction. That's why minus J5 I2 minus I1. That is over. For this mutual inductance, we have to write. For that mutual inductance, that is minus J2. Why minus J2? I2 is leaving the dot. I1 is entering the dot. That's why minus. We are traveling along current direction. That's why 1 minus. That's why 1 minus. We are traveling along I2 here. That's why minus. What is the current through that? Here, how we are writing V1? V1 is voltage across the first coil. We'll see this, then we'll go there. What is the V1? V1 equal to L1 is self-inductance of the first coil. L2 is self-inductance of the second coil. M is the mutual inductance between the two coils. V1 equal to L1 di1 by dt plus or minus M multiplied by di2 by dt. So the potential V1 is contributed by current in the second coil, because M is because of second coil, di2 by dt. In the same way, V2 is equal to self-inductance in the first coil, second coil, plus or minus. This is depends upon convention, dot convention, multiplied by M di1 by dt. Because this M is because of I1. If you consider that, here first let us once again see the first equation. 50 angle 0, 50 angle 0. Why plus 50? Because we are traveling from minus to plus. Minus 3 plus J4. We are traveling along current direction. That is over. Now, for this J5, I1 minus I2, that is also over. Now, we have to write for this mutual inductance and this mutual inductance. For this, the current is I1 minus I2. Because for mutual inductance, to find voltage, we have to consider the current in the other branch, not this branch. That's why this is for mutual A. Let us assume that this mutual inductance B. This is for B. This is for B. I understand this. In the same way, if you write like that, now come to that second loop. Minus Y minus, because we are traveling along current direction. Minus J6 multiplied by I2. Then you first write for this minus Y minus I2 minus I1. That's why minus J5, I2 minus I1. Now for this only, for this, the current is I1. Current is I1. Here, why M is minus? Because I2 minus I1 is leaving the dot. I1 is entering the dot. That's why this is minus. This minus is because we are traveling along I2 direction. That's why this I1. Now we can solve. If we solve this, what you will get? J6 I2 minus J5 I2 plus J5 I1 plus J2 I1 equal to 0. Add all I2 together. What you will get? I2 together 6 and 5. That's why this implies JI2. That's all. If you add I1 together plus J7 I1 equal to 0. This is second equation. This is second equation. J13 3 plus J13 I1 minus 7J I2 minus J7 I2 equal to 50 angle 0. This is first equation. So what you will get is J7 I1 plus J I2 equal to 0. This is second equation. If you put this in matrix form, you will get 3 plus J13 I1 minus J7 and J7 1 J I1 I2 equal to 50 angle 0 0. Find I1 I2. I1 equal to what? I1 equal to modulus of 50 angle 0 0 minus J7 J divided by 3 plus J13 minus J7 J. I1 equal to what? Find I1. Similarly, I2 equal to what? I2 equal to, both is required. Both is required. 3 plus J13, 50 angle 0, J7, 0, whole divided by 3 plus J13 minus J7, J7, J. Find I1, I2. 0.80 angle minus 87.229 and I2 equal to 5.63 angle 92.76. Now we have to find, we got I1, I2. What is potential drop across J5 is the question. Potential drop across J5 is the question. What is VJ5? VJ5 equal to J5 I1 minus I2. Is it okay? Is it okay? Not okay. Because we didn't consider M. We have to consider M. If you consider M, if you consider I1, I1 is the direction. Potential drop across J5 you found. J2, we have to consider. J2 is positive because we are considering I1. I1 is entering the dot. Here also I1 is entering the dot. That's why positive plus J2 plus this is plus. That's why this also plus J2 multiplied by I1. Multiplied by I1. So J5 I1 minus I2 multiplied by J2 I1. This is for mutual inductance M. This is for L2. If you add these two voltages together, then only, already we have seen like that only. Voltage across inductor V1 equal to L1 di1 by dt plus M di2 by dt. We wrote like that. This part is this. So now find Vj5. Vj5 equal to J5 equal to J5 multiplied by I1 equal to what? 0.80 angle minus 87.229 minus I2 is 5.63 angle 92.76 plus J2 multiplied by I1, that is 0.80 angle minus 87.229. That's all. Or any other way to find voltage across J5? Any other way to find voltage across J5? See the diagram. Any other way to find voltage across J5? Very simple. Minus. Any other way to find? Huh? Who said? Yes. What are you saying is correct. J5, this J2 is in parallel with J6. J5 and J2 are in parallel with J6. That's why, or you can find this way also. J5 also equal to minus J6 multiplied by I2 only. I2 only. Both should be equal. Then whatever you got for I1 and I2 are correct. Otherwise wrong. I got? Suppose your answer for I1, I2 are correct, then these two must be equal. Because this J5 and minus J6 are in parallel. That's why voltage across this and voltage across this are equal. They are parallel. That's why you can find the voltage across J5 by multiplying minus J6 multiplied by I2. Minus J6 multiplied by I2 you can found. So both must be equal. The first answer, second answer must be equal. Then what you got for I1, I2 are correct. Same answer. Then it's correct. So 80 angle minus 87.229 and I2 equal to 5.63 angle 92.76 is correct. What is the voltage? 33.74 angle 2.76. Here also you must get the same 33.74 angle 2.76. If you got the same value, then what you got, the current is correct. The current is correct. Yes, you are getting the same value. That's why current is correct.